Alright, hi guys. Today we're going to talk about the graphs of tangent, cotangent, cosecant, and secant. Now, these are going to be a little different than sine and cosine because there are areas where all four of these functions are undefined. And if you remember, any place where it's undefined on your graph are going to create asymptotes. So let's first start with tangent, and I'm just going to sketch out kind of my unit circle with my four angles on my quadrants. So I'm going to ask myself, where is tangent undefined? That's going to be my key places. So remember, tangent is sine over cosine. So 0 over 1, tangent is going to be 0 right here. Now 1 over 0, I have a problem up here because I can't divide by 0. 0 over 1, tangent's going to be 0. Negative 1 divided by 0, I have a problem at the bottom. So right here, this is 0, pi over 2, pi, and 3 pi over 2. So you can see that tangent has an issue at pi over 2 and 3 pi over 2 because it's going to be undefined. So looking at your graph, you can see that that forms your asymptotes at pi over 2 and at 3 pi over 2. Okay, and you can also go backwards, so at negative pi over 2 and negative 3 pi over 2. Now, to get your other points to plot, again, so we said at 0, tangent is 0. At, for example, pi over 4, my tangent is 1, so that would be right there. Okay? Alright, so let's go ahead and graph 2 tangent of 3x. Remember, this one's just your parent function, so we're going to go ahead and graph this one. One thing, actually, I want to go back for a second, and one thing I want you to notice is that how often the graph repeats itself. So this is going to be different than your sine and cosine. So from negative pi over 2 to pi over 2 is pi, and then it's going to start over and have this little, almost looks kind of like a cubic function, but it's not. So the period here for tangent is pi, how often the graph repeats itself. So just keep that in mind when we go through, because when we do our transformations, my starting point is not going to be 2 pi, it's going to be pi. Alright, so again, that's just your parent function, and then we have here. Alright, so that 2 in front is going to be a vertical stretch by 2. You don't really call it the amplitude in a tangent function, but if you want to think about it like that, you can. It is a vertical stretch by 2. And now my period is going to be the same concept here, but instead of starting with 2 pi, I'm going to start with pi over 3. Okay? Alright, so here again, so what I'm going to do is remember your period always goes, so this time remember, and 2 pi will always go on your fourth line or whatever kind of your original one was. So for pi, it always is going to go on your second line for tangent. It's a little bit kind of confusing there. So I'm going to put pi over 3 on my second line. Oops. Erase that. So that's 1/3. Okay. And then, so if you divide that by 2, it would be 1/6. So 1/6, 2/6, 3/6, and 4/6. And I'm going to do the same thing going backwards. So negative 1/6, negative 2/6, negative 3/6, and negative 4/6. Okay. And then a vertical stretch by 2. Negative 1 and negative 2. Okay, so just realize for tangent, remember it's going to be different. So your period is pi, and I'm going to put whatever my period is on the second line. Okay, so now my asymptotes here. My asymptotes are always going to fall on whatever your, so whatever your first line is. So pi over 2 and then 3 pi over 2. So your first and your third lines. Okay. So pi over 6, and remember you denote asymptotes with the dashed lines, and pi over 2. and then negative pi over 6, and negative pi over 2. So for tangent, remember it's always on the first and the third lines. Okay, so then now we just have to fill in what our graph looks like. So this one has a vertical stretch by 2, so it's going to be 0 in the middle, but instead of going to 1 right here in the middle, I'm going to go up to 2. And up to 2. And there you go. All right, let's talk about real quick the domain and range of this. So the domain here would be all real numbers except x cannot equal pi over 6 plus, okay, so remember x cannot equal your asymptotes. So my first asymptote I'm going to write as pi over 6 plus there's an asymptote occurring at every what? So 1, 6, 2, 6, 3, 6. Okay, so I'm adding, in order to get to my next asymptote, I'm going to add, so this we said was 1, 6, 2, 6, 3, 6. So I'm adding 2, 6, or 1/3. So I'm adding pi over 3k. So what do I mean by k? I just mean that's any integer. So I'm going to add 1/3, but then I'm also going to add 2/3. There's going to be another asymptote right here, right here. I forgot you can't see my screen. And then to the right, etc. And we're going to say where k exists as an integer. Okay, so the first asymptote is at pi over 6 plus every pi over 3. And remember, integers can also be negative, so that also takes care of the left-hand side. Now my range is pretty easy. It goes all the way down and all the way up, so that's just negative infinity to positive infinity. All right, so we graphed one by hand. So this one, all we're going to do is we're going to find the domain and range, okay, and write the transformations. So first, to write the transformations, the negative in front is a flip or reflection over the x-axis. This right here is going to move it left pi over 4. My period is going to be pi because I have no number in front of my x, so I don't have to divide it by anything. And then I'm going to move it up 1. Okay, so I'm going to go ahead and just sketch like where my asymptotes will be because that's what I'm going to have to use to determine my domain and range. So normally, since I haven't changed my period, I'm going to go ahead and this right here will be the same as my original parent function, and that right there will be pi. So that makes that pi over 2, 3 pi over 2, and 2 pi. All right, so then next, what I'm going to do is, so normally where my asymptotes would be is on the first lines and the third lines. All right, however, what we're going to do on this one is we're going to move everything left pi over 4. Now you notice I don't have a tick mark there, but 1/4 is half of 1/2. So all of my lines are going to go, let me actually make that a thicker line, in the middle. And that's where your asymptotes will be. Okay, so my domain, therefore, will be x cannot equal pi over 4 plus, okay, so how long did I take to get to the next asymptote? Well, my next asymptote is going to be, so this is 1/4, and then this is going to be, let's see, so it's in between pi, which is a whole, and 3 pi over 2, so that's going to be 3 pi over 4, no, 5 pi over 4, 5/4, okay? So you can see that I added 4/4 right there. So I'm going to basically add a pi each time. So plus pi k, where k exists as an integer. Okay? And you'll notice that that's the same as your period, because it's how often your graph repeats itself. And the range is, again, just negative infinity to positive infinity. And that's tangent. All right, so cotangent is very similar. If we think about where cotangent is undefined, it's going to be the opposite. Oops. Whoa. There. It's going to be the opposite of where tangent is undefined. So cotangent is undefined right at 0 and at pi, because it's cosine over sine. So you can see that your asymptotes now have shifted, and you have an asymptote at 0 and an asymptote at pi. So instead of being on the first and the third tick mark, it's going to be on the, you can think about it, I guess, at the 0th and the second tick mark and the fourth tick mark. So that's what cotangent is going to look like. So what we're going to do is maybe graph one of those, okay? And we'll go ahead and write out all the transformations. So this is going to flip over the x-axis. It has a vertical stretch by 4. And then again, my period is still pi, okay? And so then I'm going to take pi and divide it by 1/2, and that gives me 2 pi. Okay, so 2 pi is going to go right here, so I have pi, 2 pi, 3 pi, and 4 pi. Negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. So remember, your asymptotes here are going to occur on the at 0, and we're not moving them left and right at all, because cotangent is undefined at 0. And then it's going to occur again at your second tick mark, and then your fourth tick mark. So 2 pi and 4 pi. Negative 2 pi and negative 4 pi. Okay. All right, so now I'm going to do this last one all together. So flip over the x-axis and a vertical stretch by 4. So you notice cotangent normally is decreasing, and it's vertically stretched by 4, but this time we are going to flip it. So it's actually going to look like tangent since it's flipped. So we're going to start down at the bottom, and since it's reflected, it's actually going to be increasing. So my domain is x cannot equal 0 plus 2 pi k. And you don't really need that 0 there. I just always start at the first asymptote, where k exists as an integer. And then my range is negative infinity to positive infinity. And notice this guy is increasing because I flipped it over the x-axis. All right, next we have cosecant and secant. Okay, so for cosecant and secant, I think this also might have gotten flipped in your packet, so make sure that your page looks like this. Cosecant and secant are reciprocals. So what you're going to do is for cosecant, you're going to graph sine first. Okay, and then for secant, you're going to graph cosine first. Okay, and then we're going to find the reciprocal of that, find the asymptotes, because remember, whenever cosine equals 0, for example, whenever cosine equals 0, we have something that's undefined, and therefore we're going to have an asymptote there. Okay, so you can see these examples here. So cosecant, whenever we have sine equaling to 0, you have an asymptote, and then you kind of have these little baby parabolas where these graphs are going to approach those asymptotes but not touch them. Okay, and let's talk about the period for these. So the period for these of how often the graph repeats itself, well, let's look. So it starts over here at pi over 2. Is probably the best way to think about it, or negative pi over 2, and then 3 pi over 2. So how often does it take the graph to repeat itself? That would be negative pi over 2 plus 3 pi over 2, and that would be, well, I guess I really shouldn't add them. Okay, and so that's going to be 2 pi. So the difference between those, if you subtract 3 pi over 2 minus pi over 2, that gives you 4 pi over 2, which is 2 pi. So the difference to get from here to here is going to be 2 pi. All right, so let's go ahead and graph one with a transformation. So let's go down to 2 secant of x minus pi over 2. Okay, so this has, first of all, cosecant is 1 over sine. This has a vertical stretch by 2, and we're going to go right pi over 2. Okay, so the very first thing I'm going to do is I'm going to graph sine of x with a vertical stretch of 2. Okay, so here's what that is going to look like. So I know sine of x has a period of 2 pi, and that's why if we go back to the example I just showed you, cosecant of x should also have a period of 2 pi. So it's going to look exactly like what I just showed you in a couple videos ago. The fourth one should be 2 pi, 3 pi over 2, pi over 2, and then go negative. Okay, so, and then a vertical stretch of 2. So I'm going to go ahead and graph sine. Probably should have chosen a different color, but that's okay. All right, so next what I'm going to do is I'm going to go ahead and move it right pi over 2. I want to do all my transformations first. So right pi over 2 is 1 tick mark on my graph. Okay, and then I can graph that. All right, so now remember, cosecant does not exist when sine is negative. So whenever this purple graph crosses the x-axis, this graph does not exist. So I'm going to go ahead and draw my asymptotes in wherever the purple graph crosses the x-axis. And then the last step is to just draw in, you can call them your little baby parabolas. And that's the function. So let's go ahead and do the domain and range. The domain, where do your asymptotes not exist? Okay. So here we have our first asymptote at x cannot equal pi over 2. Now you notice that it also comes back to equal 0 at 3 pi over 2, which is just pi around your circle. So plus pi k, where k exists as an integer. All right, the range is also a little bit tricky, so we got to go from the bottom to the top. So at the bottom, it's going down, so negative infinity, and then we have to stop right here at my maximum, okay? And that's at negative 2, including negative 2, union, then I can start up again at this minimum, because remember, all of this is not really included in my graph. That's not really the cosecant function. It's just what I use to graph it. So I start up again at positive 2, and I go to infinity. We're going to do one more example with secant, which is very similar, and you'll probably get the hang of it there too. Okay. All right, so let's go ahead and do the next one. So this one is 2 secant of 3x. So, whoops. Here again, I have a vertical stretch by 2. Okay. I have right here, this 3 means my period of, again, this one is secant, so I'm going to be dealing with cosine. So my period is going to be 2 pi over 3. So 2 pi over 3 is 2/3. So I'm going to go 1/6, 2/6, 3/6, 4/6. 2/6 is pi over 3, pi over 2, and then I'm going to go backwards. Alright, and then the same thing. Alright, so I'm going to go ahead and graph in cosine with a vertical stretch of 2. So that means I start up at 2 and then go down. Alright, so this one I don't have to move left or right at all. I've already accounted for that period change. So I'm going to go ahead and draw in my asymptotes wherever this guy crosses the x-axis. Okay, so those are your asymptotes. And then we have to draw in our actual graph. And how you're going to do that is the little parabolas that approach those asymptotes but not touch them. Alright, so lastly, let's do the domain and range for this graph. So the domain is x cannot equal, so let's look at our first one, was pi over 6. First asymptotes, that was 1/6, 2/6, 3/6. So I added 2/6 to get here, to get to my next asymptote. So plus pi over 3, because 2/6 is really 1/3, right? So plus pi over 3k, where k exists as an integer. All that's saying is it can be positive, it could be negative, but I can't add like 0.5, okay? It's got to be a whole number. All right, and then my range. So negative infinity, because I'm coming from the bottom, all the way up to my maximum here, which is -2, union 2 to infinity. Okay, so that's what those are going to look like. I'll leave the last two for you if you want to practice them. But that's what secant, cosecant, tangent, and cotangent are going to look like for your graphs, and that's all.